In this video, we are going to work on simplifying expressions that contain exponents. The first thing I recognize is that all of these terms, we have three terms, each contain the same base x. So I can start by multiplying the coefficients. And if you feel comfortable using a calculator, then do so. I know that 7 times negative 3 times 2 is a negative 42. That's my first step. My second step is to recognize that when we're multiplying and we have the same base, we're going to add the exponents. Negative 8 plus negative 4 plus 0. If you need to use a calculator, then do so. So I have negative 4x. Okay, negative 8 and negative 4 is negative 12 and 0 is negative 12. I want you to recognize that this is the same as me writing these two different groups separately. And in fully simplifying this, I need to make sure that we don't have any negative exponents. The number in front can be negative, but the exponent cannot. So this has an exponent of negative 12. This has an exponent of positive 1. The negative 42 is just happy where it is. How do I know that? The exponent is positive. The x is not happy where it is. I can see that because it has a negative exponent. I move it to the bottom. I make it happy. And I have fully simplified this first exponent. Let's take a look right now at the second example. The same rules apply. I have the same base and I'm multiplying. So I'm going to start by multiplying the coefficients. And if you feel comfortable using your calculator rather than doing mental math, you're going to take 3/4 times negative 24, and I'm going to write down the value of negative 18. When you have the same base and you're multiplying, you're going to add the exponents. So negative 18 times x to the, and you're welcome to use a calculator, but 7 plus negative 10 is negative 3. I have two separate terms here. There's a negative 18 and there's an x to the negative 3. Don't be confused by this not being happy. We are looking at the exponents. The negative 18 is happy. It has a positive exponent. The x is not. Fully simplifying, I move the x to the bottom, and this problem is. Moving on to example number 3. Example 3 and example 4 are going to resemble one another. So I can see that I have the same bases here, and so I'm going to start by seeing, can I reduce this fraction? Now, most of you can just do that in your head. If you're not comfortable, we're going to take this negative sign that's on the same level as the division sign, and I move it to the top. If you're not comfortable with reducing in your head, you'll plug it in. You'll hit math one time, and when you press enter twice, it will reduce it to negative 1/4. So the first thing I do is I reduce the coefficients. It does not matter if the negative sign is out front at the same level of the division sign or if it's up above, as long as there's only one division sign. Let's go on to the x's. When we divide, we are going to subtract the exponents of the same base. I always do the top exponent, subtract the bottom exponent. If you're more comfortable plugging into your calculator, you can do so. So negative 20 subtract a negative 22 gives us a positive 2. So x to the positive 2. I always write it initially in the numerator or the top, and if it has to be moved, I do that afterwards. I'll do the same with y. The numerator, subtract the denominator, and these are the same base. Numerator, subtract denominator. Division turns into subtraction. So negative 7, subtract 3, we get a negative 10. I always write it initially in the numerator, and now I go back. Is the 1 happy? Yep. Is the 4 happy? Yes. What about the negative sign up front? That's fine. We are only focused on the exponents. We are only focused on the exponents. Is this x happy being on top? Yes. Why? Because it is positive. Is the y happy being on top? No. So I have a negative 1/4. The x stays on top. The y goes to the bottom. And I've fully simplified example number 3. Example number 4 is like example number 3. The first thing I'm going to do is I'm going to work at reducing the coefficients. Now, some of you will just do that in your head. That's fine. If you're not comfortable, you can type in -30 divided by 5. We end up with a -6. Remember, -6 can be written like this, or you may choose to put a 1 on the bottom. That's totally up to you. The negative sign can go up top, or it can be on the side. Either would be fine. I'm going to start with the x's. When you switch from division, and now we're simplifying these, we're combining division turned into subtraction. It's always the numerator, subtract the exponent of the denominator. Okay, so I'm typing in 3 subtract -4. I know I get 7, but you're welcome to go 3 subtract -4. And you can see you also get an answer of 7. I'll do the same for the y's. It's the numerator, exponent, subtract the denominator. I can see 2 negatives make a positive, and I should end up with 20. We always write them on top, and then we decide, do I need to move things? So the 6 and the 1, they have hidden ones. So is this -6 happy? Yes. Is the 1 happy? Yes. Is the x happy? Yes. Is the is the y happy? Happy just like it is. In the first 2 examples, we worked on if you are multiplying, right? If you're multiplying, you add the exponents. And then 3rd and 4th example, if you're dividing, you subtract them. Now, on the last 2 examples, I am trying to review what do we do when we have an exponent outside of a group. This exponent has to be shared with everything inside. So before I even start sharing it, I need to make sure everything inside has a visible exponent. Exponent, exponent, exponent. I don't see an exponent. I put an exponent in there. It's a hidden 1. Now, every time I make this shape, I have to multiply. So I'm going to start here. This is 2. 1 times 2 is 2. 3 times 2 is 6. -2 times 2 is -4. 4 times 2 is 8. And I'm 2 steps away from fully simplifying this. 2 to the 2nd power, feel free to use a calculator if you need to, but 2 times 2 is 4. The x is happy, it stays where it is. The y is not happy, it goes to the bottom. The z is happy, it stays where it is. Now some students will say, does it matter if I put y to the 4th in front or back? It does not matter. Make sure your phones and your earbuds are put away. So for this problem, I'm going to look before I distribute, and I need to make sure everything inside has a visible exponent. Yes, yes, I don't see an exponent, and I don't see an exponent. Now, every time I distribute from this value to an exponent, you are always going to be multiplying, every single one. So I'm going to write this. 1 times -3, the exponents. 1 times -3. 1 times -3. 2 times -3. -5 times -3. And now I need to simplify. Is this 2 happy on top? No, it's going to go down to the bottom. Now it's happy. Is the 5 happy on the bottom? It is not, so it goes to the top. Is the x happy on top? It's not happy, it goes to the bottom. And the y is happy on top. Now grab your calculators. We did so much work. We did it well. And the last thing I want you to do is think that this is 5 times 3. This is 5 to the 3rd, or 5 times 5 times 5, which is 125. And 2 to the 3rd is not 2 times 3 is 6. It's 2 to the 3rd is 8. 2 times 2 times 2.